What if the future of energy storage doesn't look like a battery at all, but like a building that moves?
Wait, a building that stores energy? That sounds impossible.
It sounds strange because most people imagine batteries as boxes, but the real problem is much bigger. The world needs to store massive amounts of renewable power, and we need ways that can scale fast.
So this is not just about one cool invention. It's about whether the grid can keep up?
Exactly. And that's why today we're comparing two ideas that look similar on paper: gravity batteries and pumped hydro. Same basic physics, very different reality.
Okay, before we'll break it down simply for us, hit like and subscribe to our channel.
True, that helps us make more of these videos.
Right, so what is a gravity battery?
A gravity battery stores extra electricity by using it to lift heavy blocks upward. When the grid needs power again, those blocks are lowered, and the motion spins generators to send electricity back out.
So it's basically use electricity now, store it as height, get it back later?
Exactly. No chemistry, no lithium, no fire risk, just mass, motion, and gravity.
And pumped hydro does the same thing?
Same principle, different setup. Pumped hydro uses surplus electricity to move water uphill into a reservoir. Later, that water flows back down through turbines to generate power.
So why aren't we building pumped hydro everywhere if it already works?
Because pumped hydro has a huge catch. It usually needs the right geography: hills, valleys, reservoirs, and a lot of space. That makes it powerful, but hard to replicate quickly.
And gravity batteries don't need all that?
Much less. That's the big twist. Gravity batteries can be built on industrial land, near cities, near substations, even in places where a giant reservoir would never work.
So the same idea becomes easier to place?
Yes, and that difference is everything. One technology is limited by terrain, the other is limited mostly by engineering and planning.
But which one is actually better?
That depends on the job. Pumped hydro is the older benchmark. It's proven, large-scale, and already responsible for a huge share of long-duration storage worldwide.
So hydro wins?
Not so fast. Pumped hydro wins on maturity. Gravity batteries win on flexibility. If you can't find a mountain, a lake, and the right permits, hydro can't happen at all. Gravity storage can still be built.
That sounds like the real problem. Not ideas, but permission and geography.
Exactly. And that's why this is such a big story. The world doesn't just need cleaner electricity. It needs storage that can scale with demand, because demand keeps rising.
So storage is the thing holding the transition together.
One of the biggest things, yes. Solar and wind are growing, but they don't always produce when people need power. Storage is how you bridge that gap.
So where does China come in?
China is already showing what this looks like in the real world. In Rudong, China built a commercial-scale gravity battery tower, proving that the concept is not just a lab experiment.
But today we're not making that the main story, right?
Right. Rudong is the proof point. The main story is bigger. If gravity batteries can be built more easily than hydro, then the question becomes, why isn't the rest of the world moving faster?
And that's where the West is behind?
In many places, yes. The West has the engineering talent, but projects often get slowed by permitting, site limits, and fragmented energy rules. Meanwhile, China is turning one working idea into a repeatable playbook.
So the lesson is not China invented everything, but China is scaling faster?
Exactly. And scaling is what matters when energy demand is rising everywhere.
If gravity batteries are so flexible, why build pumped hydro at all?
Because hydro still matters. It's proven, efficient, and can store huge amounts of energy where the geography is right. But it's a local solution. Gravity batteries are more like a modular answer.
So hydro is the old giant, and gravity batteries are the new flexible contender.
That's a good way to put it. One is a veteran. The other is a shapeshifter.
And if we get this wrong, the grid can't keep up with the energy transition.
That's the real warning. If we want more renewables, we need storage that can be built in more places, faster, and at scale. The future won't be won by the prettiest idea. It'll be won by the one that can actually be deployed.
So the real question is not, which one is cooler?
It's which one can help us power the future before demand outruns the grid.
And right now, gravity batteries might be the one to watch.
Especially if the world starts copying what China has already begun in Rudong.
So the real answer isn't just which tech is better, it's which one can scale fast enough to help the grid survive rising energy demand. And right now, gravity batteries and pumped hydro are fighting that battle in very different ways. And if you want the full story behind Rudong, the giant gravity battery China already built, go watch our previous video next.
Yes, on the Rudong Gravity Battery Station.
Then subscribe and follow the Green Blueprint _TGB for the next sustainability story.
Thanks for watching. Stay green, stay healthy, stay informed.